Okay, so now let's build on what we just saw in example 1 and use it to and apply it to special right triangles. So example 2 says find all 6 trig functions for 30, 45, and 60. So that means we have to draw 2 triangles here, a 30, 60, 90 and a 45, 45, 90. So let's draw a 30, 60, 90. Alright, I'll make this 30 degrees. And since all triangles with the same angles are similar, it doesn't matter what I call this side. So I'm just going to call it 1, because if I called it 2, no matter what, since it's a 30, 60, 90 triangle, like this side divided by any other side will have the same ratio as another triangle that's just scaled up or scaled down. Alright, now a 30, 60, 90 triangle is like it's like a half of a equilateral triangle. So if I drew another one like this right here, okay, and identical, so that side was 2. Now, if we look, this entire angle here would be 60 degrees. Which makes this entire side 2, which makes this side here 2 as well, because it's now an equilateral triangle. All the angles are 60 degrees. So if I get rid of all that stuff now, that's why in a 30, 60, 90 triangle, the hypotenuse is always double the short leg, because it's like a half of a equilateral triangle. Then if we did the Pythagorean theorem, this angle right here would be root 3. Okay? And since we're going to need it later, let's do the 45, 45, 90 triangle. Okay, that's like a half a square. Okay, so 45, 45, 90. By half a square, I mean if you put another one here, you have a full square. Complete the square. So now, if we just call one of this leg 1, then this leg also has to be 1 unit long because it's an isosceles right triangle. Then if we do the Pythagorean theorem, we get root 2. Alright, so since these angles are equal, the legs have to be equal, and then do the Pythagorean theorem to find the other side. Alright, and those, now, you know, again, if I called this like 6 and that 6, then this side would just be 6 root 2. Alright, so it doesn't have to be length 1, but no matter what, the ratio between these sides or these sides is always going to be the same for all 45, 45, 90 triangles because they're all similar. Alright, all similar figures have the same angles and proportional sides. Okay, so now let's use these pictures to fill out the table. Alright, so the sine of 30. Alright, so 30 is opposite over hypotenuse, so it's going to be 1/2. Okay, the cosine of 30, so cosine is adjacent over hypotenuse, so that's going to be root 3 over 2. Okay, the tangent of 30 is going to be 1 over root 3. Alright, which we're going to rationalize by getting rid of this radical in the denominator, and we get root 3 over 3. Alright, tangent is opposite over adjacent. Okay, now for 45, we're going to do the same thing, but using the 45, 45, 90 triangle. So for the sine of 45, we're going to do oops, did not mean to do that. Sorry. We're going to do opposite over hypotenuse. So we get 1 over root 2, which will rationalize 1 over root 2. We'll get rid of the radical in the denominator, and it becomes root 2 over 2. Okay, the cosine of 45 is also adjacent over hypotenuse, so it's also going to be 1 over root 2, which simplifies to root 2 over 2. Okay, and the tangent of 45 is going to equal 1, because the ratio of the opposite leg over the hypotenuse, it's the same length, so it's a 1-to-1 ratio. Now for the sine of 60. Okay, so we're going to go back to this triangle over here and use 60 now. So we get opposite over hypotenuse, root 3 over 2. Okay, adjacent over hypotenuse, 1 over root 2. Opposite over adjacent, root 3 over 1. So it's just root 3. Okay, so now we have the bulk of our table filled out. Now for 0 and 90, alright, I promise this will make more sense when we learn new definitions of trig. But our current definitions of trig, meaning SOHCAHTOA, is limited because it's all based on right triangles, and you can't really have a right triangle where this angle is 0 degrees, because if it's a right triangle, that angle is 90, and by the triangle sum theorem, this angle would be 90. So this picture doesn't really make sense. But if we try to make sense of it, and again, this is not a good way to do 0 and 90. In order to do sine, cosine, tangent of 90 and 0, you need new definitions, which we will learn. But for now, let's try to understand it using our current definitions. So if we had a right triangle, and again, this is strictly theoretic, it's not something that you can actually make, because again, this is 0 degrees, so like it would look like this. It wouldn't look like an angle. Like this would have no distance between the sides. Okay, but let's hypothetically say it for a second. That angle is 0. Well, then that side would be 0. It would have no length if this was 0 degrees. Okay, and let's say this side was 1. For just, let's say, I could say whatever I want. Well, it's an isosceles triangle because the base angles are equal, so that side would be 1 as well. So if you were doing the sine of 0, it would be opposite over hypotenuse, and you get 0. Okay, if you were doing the cosine of 0, it would be adjacent over hypotenuse, so it would be 1. If you were doing the tangent of 0, it would be opposite over adjacent, it would be 0. Right? And again, this doesn't really make sense, and it's okay if it doesn't, because this is not a practical triangle you can make. But for now, it'll make more sense later, but for now, you should know the sine of 0 is 0, the cosine of 0 is 1, and the tangent of 0 is 0. Okay? Now, if we do the same thing, but with 90, okay? If we look at 90 and we do opposite over hypotenuse, the side of 90, we get 1. Alright, if we do adjacent over hypotenuse, we get 0. And if we do opposite over adjacent, we get 1 over 0, which is undefined. Alright, and these are the values for sine, cosine, tangent of 0, 30, and 45, and 60 and 90, that if you typed into your calculator, that's what it would tell you. Alright, but these are values that you should eventually memorize, and as we work with them, you will. Alright, so in the next video, I'll show you another way to fill out this table with like a fun, kind of like easy trick to remember this table so that you don't really have to memorize it.